So, good morning to one and all. Today we are going to discussing about operational amplifier. Seems last class also we discussed. Now last class we discussed two topics. So a brief introduction about operational amplifier and also inverter amplifier we discussed. Operational amplifier is nothing but it amplifies the weak signal into the desired signal. That means the signal is strengthened. The signal is strengthened. That means whatever the eliminated unwanted signals, that is, it will be removed and then the signal becomes strengthened. So there are so many amplifiers are there. Mechanical amplifier, electrical and electronic amplifier, and fluid amplifiers, optical amplifiers are there. In mechanical amplifier, already we discussed. That is some lever arrangement. I discussed with you. Here, the amplifier, the gain of the amplifier is nothing but the output. Output by input is nothing but output by input is nothing but a gain. Then in the mechanical amplifier, see here, this is a one beam, and then here one pivot is it is fixed at this portion. It is the length varies L1 and L2. L1, this is L1 length, and this is L2 length. And then here, when the force is acting at one end, and then the displacement should be more. That means here the small amount of the at the end of this beam, we can get the other end a large displacement. That means, for example, if consider this is a y movement and this is x. So here the x is the small displacement, and here y is the large. That means magnification takes place. In mechanical amplifiers, magnification means the amplifier is nothing but, in other words, from small to large displacement. For example, if you take in a fluid amplifiers, the piston, the movement of the piston in the cylinder containing liquid, and then when a small displacement of the piston then gives a large movement of the fluid in a small tube. So like that, that is a large magnification. That means a cylinder, the piston, cylinder containing fluid, the piston. Here, when the piston moves a small displacement in the cylinder containing liquid, then automatically a large displacement of the liquid from the output, which is entering into a small diameter of a tube. So like that, that is called fluid amplifiers. And then like this, the electrical and electronic amplifiers. And also if you see optical amplifiers, in the optical amplifiers, see our specs only. I told to you that that is both of them. If you see in that mirror, then whatever the small particles will appear in a large particles, right? See our microscope, right? In a lab, metallurgy lab, you are you are doing that microstructure of copper, aluminum, like that, right? So with the help of the microscope, you are observing the structure. That means it's small will appear as a large. These are optical amplifiers. That means we can get the correct one. That means we can get the correct one, whatever our required one output. The next one. Here the operational amplifier is a linear integrated circuit. I told you that linear integrated circuit is nothing but IC chip. It consists of number of resistors, capacitors, transistors, diodes, which is arranged in that integrated circuit chip, and then it performs for specific purpose. That is called integrated circuit. And here in this, an operational amplifier is nothing but it is a linear integrated circuit that is having a very high voltage gain, as well as high input impedance and low output impedance. That means voltage gain in this operational amplifier is a high gain DC amplifier. That is a nearly 1 lakh, nearly 1 lakh. And then high input impedance means the input impedance, that is a resistance in the input, it is not clear, that is high. Where and low output impedance, almost all whatever the output we are getting with a low resistance level, means almost all the error is minimized. So that means in the operational amplifier, it is nothing but a linear integrated circuit or IC chip that it has a high voltage gain, that is high DC gain amplifier, that is around 1 lakh, and high input impedance and low output impedance. And this is the symbol. This is the symbol of the operational amplifier, right? And then the ideal amplifier having infinite voltage gain, infinite input impedance, and zero output impedance. Actually, that is ideal amplifier. The ideal amplifier uh, is that is infinite. It is having infinite voltage gain, infinite input impedance, and zero output impedance. If you see clearly, this operational amplifier, it consists of 2 dozen transistors, 1 dozen resistor, and 1 or 2 capacitors. This operational amplifiers. And sometimes to get this one, the amplifiers also we have to connect in series also. So to get the output clear, it is a negligible output impedance. To get our output a negligible impedance output, that is here it is a low impedance. I'm saying that negligible output impedance. So for that we have to go for some arrangements, maybe a series in amplifiers like that. Then if you see clearly here in this, it is having a inverting input, so that is minus, this is minus, and non-inverting input, that is a plus, this is a non-inverting input. And then negative voltage supply and positive voltage supply, and two offset nulls here, and one output. This is the output. These are the pin functions of the operational amplifier. Totally 8 pins are there. Totally 8 pins. Next, we'll go for the next slide. And that is the applications of these amplifiers: inverter, voltage comparator, buffer amplifier, differential amplifier. There are so many are there, the applications of the amplifiers. The next, we will discuss about the inverter. Already we discussed in the last class. Again, I'm repeating. All of you listen carefully. Inverter, right? This is operational amplifier symbol. This minus indicates it is inverting end, and plus is non-inverting end. This is connected to the ground. This is connected to the ground. And here one resistor is there at the inverting end, that is the input of the voltage supply. And another feedback resistor is arranged, which is from the output of the amplifier to the inverting end, to the input. That is, here this RF is connected. The feedback resistor is provided, that is from the output through the inverting. That means through the resistor RF, and it is connected to the inverting end. This is the inverting end. That is the input. So now from this voltage, that is gain. Gain is nothing but voltage gain is nothing but this is the formula I told you, that the gain is nothing but output by input. Here V0 by Vi we have to find out. So in this, yet here the input to voltage, the current is passing through the resistor R1 and the resistor RF is the same. So VIN is equal to IR1. This is all of you know. The current passing through this resistor is I, and R1 is the resistance, and VIN is the voltage at the input. And that means we have to find out the voltage at the input and the voltage output voltage both. So then only we can get the voltage gain. So input voltage and the voltage output voltage is here the current is passing through this resistor RF is also the same, that is IRF, but here it is a minus, that is it is arranged to the feedback. And if you go clearly, this is the potential difference across RF. That means the potential difference across this resistor RF is nothing but Vx. This is the point Vx minus V0 is equal to Vx minus V0. So if the Vx is equal to, that means at this point the voltage is 0. So Vx is equal to 0, it becomes minus V0. The difference between these two, V0, Vx minus V0, Vx minus V0. So it is V0 minus V0. Now substitute the value of Vin and V0 in this one. Then we can get both II gets cancelled, and then we can get RF by R1 minus. So if RF is equal to R1, then it becomes V0 is V0 by Vi is equal to minus 1. V0 by Vi is equal to minus 1. Actually, it is minus 1. So V0 is equal to minus Vi. That is the inverse. That means output voltage is the same as that of the input voltage. But here, when the see here in a household appliances, when the power is unexpectedly is in off, shut off, then automatically the inverter ons with the same voltage. So that is the. Any questions from this? Any questions? Any questions? Next, we'll go for the next one. Anybody, if there is any questions, you can post in the chat box. Then a summing amplifier. So like this, so amplifiers are there. Next, summing amplifiers, adder or summing amplifiers. Here, this is if you need, you can write down on the pen, on paper. That means you can write down with the help of the pen on the paper. These are all the things, circuit diagrams. Anyway, today by the evening, I will share this one. Right? So all of you write down if possible. So while I am telling you, if you write down on the paper with the help of the pen, then you can clearly understand. So here in this three resistors are there, RA, RB and RC. RA, see here RA, RB and RC. And then here the voltage across this resistor RA is VA and RB is VB and RC is VC. And the current passing through these resistors are IA, IB and IC. These three resistors are in parallel. And yet here the current is I. That here the current is I. So that means I is equal to IA plus IB plus IC. See here, IA plus IB plus IC. Here, at this when the current came at here, according to the Kirchhoff's laws, the current, the number of current directions passing and at one junction, and the output is same. That is here, the IA, IB, IC at this junction, and the output of this is the same. That means I is equal to IA plus IB plus IC. That is that is the sum of the currents of the resistors of IA, IB, and that is IC. So now from this IA is nothing but here IA is equal to VA by RA. That means, so you know that V is equal to IR, right? V is equal to IR. Right? The current passing through the resistor RA, that is I is equal to V by R. V by R. I is equal to V by R. So that means VA by RA. So IB is equal to VB by RB. IC is equal to VB by RC. So we can get all the currents for resistors, that is A, resistor A and resistor B and resistor C, 3 resistors which are connected in parallel. And then here same, here instead of the previous in the inverter, the total of 3 resistors, only 1 resistor is there, but here 3 resistors which are connected in parallel. And then same RF resistor is there, which is connected from the output to the is provided, this feedback resistor is provided from the output to the input, that is inverting end, which is connected to the inverting end. And then same here, from this we can get the IA, IB and IC value. And the same current I passes through the feedback. That means here what I said here, from this point, this is nothing but I. The same current is passing through the feedback resistor. Same passes through the feedback resistor. The potential difference across RF is nothing but the same. Similarly, the previous Vx minus V0. It becomes a Vx is equal to 0, and then we can get minus V0. And so I is equal to, from this current, I is equal to minus V0 by RF. So I is equal to the current passing through the resistor RF. So this is I is nothing but the current passing through the resistor RF is equal to minus V0. That is actually V by R. So we are finding out the current passing through this this resistor RF. So then it is V0 is nothing but minus V0 because it's feedback by divided by RF. So here in this now this capital I, we have to substitute in the main equation. This is the main equation, right? We have to substitute the value of I in this equation, and IA, IB, IC also we have to substitute in this equation. So right, this value, I value and IA, IB, IC value substitute in this equation. This is the main equation according to the Kirchhoff's law. And then on simplification, we are getting, we have to go for simplification, right? This value. Then if RA, RB, RC is equal to RAF, then the output voltage is nothing but the sum of the voltages in the resistors A, B and C. So this is the last equation. The output voltage is equal to the sum of the voltage of resistors A, B and C. When it is if RA is equal to RB is equal to RC is equal to RF. Now it is clear. This is a negative thing. V0 is equal to minus of VA plus VB plus VC. That means here this operational amplifiers is employed. That means with mathematical operations like addition, subtraction, multiplication, division, differentiation, integration, like that. Again, I'm repeating. These amplifiers are employed with the some mathematical operations like addition, subtraction, multiplication, division, differentiating, and integration, etc. Maybe. So now it is clear that this one. I think all of you understand. Any questions? Any questions? These are all the things you know. The how the parallel. This is right. Right. This is all of you know. This is simple, fundamental in electrical and electronics. What we discussed. So with this formula, V is equal to IR. Next, we'll go for the next slide. Integrating amplifier. In integrating amplifier, this now here the same resistor RF. Here in the feedback in the previous summing amplifier and inverting amplifier, we are arranged in the feedback path resistor RF. But here we are arranging a feedback a capacitor. We are arranging a capacitor in the feedback path from the output to the input, that is inverting end. And R is the resistor which is connected to the inverting end. It is connected to the inverting end. So here the difference is, here the capacitor is there. The previous RF feedback resistor, but here we are arranging in this integrating amplifier, capacitor is arranged. See here, consider an inverting operational amplifier circuit. This operational amplifier we can also call as op amp. Simply we can also call as op amp. Simply op amp. Right, with a feedback through a that is op amp circuit with feedback through a capacitor. The current is rate of the movement of. I think all of you know that current is nothing but the rate of the movement of the charge. And so the charge in the capacitor Q is equal to C. With this formula also you know very well. Q is equal to CV. That is charge. That is the charge. Q is equal to CV. And V is the voltage across it. Voltage, that means the voltage across the V is nothing but voltage across this capacitor. So the current through the capacitor is nothing but I is equal to dQ by dt. So here Q is nothing but a CV, right? Q is nothing but here CV. So C is constant, C dV by dt. C dV by dt. So here d by dt Q, right? Here in the place of Q, we have to substitute CV. CV. So C is constant, it is nothing but dV by dt. The current through the capacitor is C dV by dt. And then see the potential difference across the capacitor C, same Vx minus V naught. Vx, so there is a minus V naught. This is same because it is a feedback. It is arranged. The capacitor is arranged feedback path. The output voltage is minus V naught. And here see the current through the capacitor is nothing but I. This is I. I, right? I is equal to that is this is the current through the capacitor, right? This is the current through the capacitor. I is equal to C dV by dt. So we have here you have tried out. So d in the place of V it is minus V naught. We have to substitute dV naught by dt. dV naught by dt is not clear in the dV naught by dt, right? Minus, it is minus. So again I'm repeating, all of you clearly see here. Here the current through the capacitor, here the current through the capacitor, nothing but I is equal to dQ by dt. Here Q is nothing but CV. If you substitute CV at here, C is constant, that is capacitance. So it is dV by C into dV by dt. So now if here the capacitor is arranged from the output to the input, so then it is so the current through the capacitor that is here, this is I, this is I. It is not clear. The C dV naught by here in the place of V, it is a dV naught, dV naught, dV naught, right? dV naught by dt, right? Here V naught is minus V naught. We have to substitute here minus. Here it is C. That is minus C dV naught by dt. dV naught by dt. So that is the current through the capacitor when it is arranged to the amplifier. So this is when it is not arranged to the operation amplifier. So that is I is equal to C into dV by dt. When it is arranged to the feedback path in the operation amplifier, then it becomes I is equal to minus C dV naught by dt. This is C dV naught by dt. And then the current through the input resistor. Now this is over. This is the current that the current is same. The current through the capacitor is I is equal to minus C dV naught by dt. And the current through this resistor I is equal to simply VIN by R. This VIN by R. Right. The current passing through the resistor and the current passing through the capacitor is same. So we have to equal these two. It means I is equal to VI by R. I is equal to minus C dV naught. But this is both will be equal. So we have to equal this one. Both will be equal. minus C dV naught by dt is equal to VIR, VI by R. So from this equation, dV naught is equal to minus 1 by RC, VIRC. That means R into C. See here, when it comes in this direction, so RC, resistor R1 and C capacitance, minus 1 by RC, VIN dt. So we have to integrate on both sides. That means we have to integrate on both sides. Then this dV naught on integration becomes a V naught, and minus 1 by RC is constant. So integrating of VI dt. This is the thing. Right? VI, otherwise a VI dt, integrating of dt. So this is the thing. So on integration. So that means we have to integrate on both sides. So we can get V naught, the output voltage is nothing but minus 1 by RC integration of VI dt. This is the formula. So for all the amplifiers, we have to find out the gain, voltage gain, or simply output voltage. So now it is clear. Any questions up to this? Integrating amplifier, anybody? Any questions? If any questions, you can post. The next we'll go for the next one. Differential amplifier. See here, in this differential amplifier, all of you note down. So you have to better note down on the paper with the help of the pen. So all these circuit diagrams and then what I said step by step. And in the differential amplifier, see here, these V1 and V2. Here, these are the two. One is, if you see clearly, see this V1 is inverting end minus, and V2 is non-inverting end, that is connected to plus, and then it is another resistor R1 and R2. Here V1, this voltage, and R1, and this is R2, and here R1 and R2. So these, if we consider this R1 and R2, these two are connected in series. Similarly, in the differential amplifier, we have to consider this R1 and R2 are connected in series. There is no current through the high resistance in the operation amplifier between the two input terminals. There is no potential drop. So here, if you see this I is equal to the current, you know that V2 is equal to, if you see correctly, V2 is equal to R1 plus R2. So this R1 and R2 are in series. That is I is equal to V by R, right? I is equal to V by R. I is equal to V by R. That means V is equal to R. I is equal to V by R. That means V2. V2 is both are in, the two resistors are in series. So in the place of R, it becomes R1 plus R2. V2 it is. V2 by R1 plus R. And then if you consider this one up to this. So here, again, see here, this R1 and R2, right? Here R1 and R2. And if you see I is equal to Vx by R2. Here from this point, the current is I at here, and the current passing through the resistor R2 is nothing but a Vx by R2. Vx by the current passing through the resistor R2. Vx by R2. If you consider this is also no problem. If you consider this is both written clearly, this is both of the points are X. If you consider this resistor R2, so it is Vx by R2. Similarly, the current. Okay, notice clear. So now here, if you see this in this V2 R1 R2 and R1 R2 both are connected in series. So if you consider the voltage, that is current through this resistor R2, and this is resistor R2, so that is a Vx by R2, voltage V by R. I is equal to V by R, right? I is equal to V by R. So Vx by R2. So now from this, both if we equate these two, because the current passing through the R1 and R2 and R2 is same. So we have to equate these both. Vx by R2 is equal to R2 by R1 plus R2, right? And the next current passing through the feedback resistance must be equal to that of from V1 through R1. That means the voltage difference across this Vx and V. That means the voltage difference across resistor R1 is nothing but V. That means the current passing through the same. That is current passing through this resistor R1 is same. Right? Here, if you see V1, Vx, this here, the voltage difference across these two is V1. That means the current is passing through the resistor R1 and this is R2 is same. So I is equal to that means both. So if you consider for this potential difference across this V1 minus Vx by R1, so that is here this total is I, right? And this is the total, the current passing through the R2 is also same. That is I, both are I. So we are equating, sorry. So V1 minus Vx by R1 and Vx minus V0 by R2. Okay, right? Now it is clear. Any questions? Here, see, the current passing through the resistor R1 is same as that of the current passing through the resistor R2. So that is I is equal to I. So now if you consider I is equal to V by R, all right. So V1 minus the potential difference, the potential drop in the resistor, that is V1 minus Vx by R1 is equal to Vx minus V0 by R2. So on simplification of this equation, we can get the value of V0, that is nothing but the output voltage is nothing but the difference of the two input voltages, V1 and V2. The difference of the two input voltages, V1 and V2. That means V2 minus V1. Are you understand this one? Here, this differential amplifier is nothing but it is the output voltage is the difference between the two input voltages. That is V1, V2 minus V0. Here, the two input voltage V1 and V2. So now it is clear. Any questions? Any questions? So you can ask. You can raise. If there is any questions, so you can ask. The next we'll go for the next one. Now it is clear. It is audible to all of you, right? It is audible. It is clear. My voice is clear to all of you. Anybody can say in the chat box. Yes. Okay. Raj. Next we will go for the next one. Differentiator, right? If you come to the differentiator, that is all of you know that here in this in the differentiator, here the resistor R is arranged the feedback, right? And here the capacitor is arranged to the inverting end. Capacitor. 1 minute. Right. Here the resistor R in the differentiator R is connected in the feedback path from output to the inverting end, that is input, and here the capacitor is connected to the inverting end, and then this non-inverting end is connected to the ground. So in this similarly in this the current passing through this resistor R is equal to V0 by R, and I in the capacitor it is IR, the current passing. So we know that in the previous already we discussed I is equal to d by dt C VIR. That is C is constant. We can write down C dV d by dt VIR. So in this output voltage is nothing but minus because it is arranged in the feedback. So the output voltage is directly, it's a simply, you can go for simply that is the current through the capacitor and the current through the resistor. So here it is minus V0 by V0 by R. It is a arranged feedback minus V0. Say both currents are equal. So minus V0 by R is equal to C d by dt VIN. So this output voltage V naught is equal to minus, that is RC minus RC d by dt VIN. That is the differentiator. So this is actually, this one, it is used in the as a differentiator to decrease the signal to noise ratio. The application, that means it increase in the signal. If there is any noise is there, disturbance is there, this differentiator will reduces the signal. This differentiator will reduces the signal. So any questions from this? Here see, in this here it is arranged. Again I'm repeating, differentiator. R is the feedback resistor, is arranged from the output to the input to the inverting end, and a capacitor C is arranged connected to the arranged or connected to the inverting end. The non-inverting end is ground, right? So again see here some, and the current through the resistor is that is current through the resistor I is equal to minus V naught by R. That is V naught is the output, this feedback. The potential difference across these 2 points we can get, it is if we consider this point is as X and V naught, Vx minus V naught. So in the Vx is equal to 0, so it is minus V naught. So minus V naught by R, and the current passing through the capacitor. Already you know that I is equal to Q by C, right? Charge. Um, already in the previous we discussed, right? The previous, again see here previous I Q is equal to C by V, I is equal to dq by dt. C therefore is nothing but if you substitute Q is equal to CV at here, then C dV by dt, same. So d C d by dt, V d VIN by dt, if you substitute here in the capacitor, if these two currents are equal, so that means here these two V naught by R and these two are equal, then it is minus V naught by R is equal to C dVin by dt. Output voltage, thereby output voltage V naught is equal to this R goes to in this numerator, then minus RC d by dt VIN. That is, this is the thing. So they especially this is used where to decrease the signal to noise ratio. The difference is okay, right? So any questions? Right. Now we'll go for the next one. And buffer amplifier. I think this is the last one. Yes, this is the last one. We'll discuss buffer amplifier. Then I will take the attendance. So of course the time is over, right? It is time is 10:45, right? Okay, right. It will take 5 minutes time to complete. Buffer amplifier or voltage follower. See here in this, if you see clearly, this is the inverting end, and this is the inverting end, and this is the non-inverting end. Here see the output voltage is connected to the inverting end directly. The output here the voltage only here. Here the voltage, first if you supply the input voltage, then that becomes the output voltage. That output voltage is supplied to the input same voltage. So this is the you can call this a buffer amplifier or voltage follower. Voltage follower, the same voltage. We are getting the output voltage is nothing but is arranged the feedback to the input, that is inverting end. Same output voltage is connected to the inverting end. It is the output voltage is same as that of the input voltage. The buffer amplifier is essentially as an impedance. It is used in a transformer, right? Essentially it is impedance transformer, which consists of a voltage at high impedance to the same voltage of, that means here at the input the voltage having high resistance is converted into this voltage of negligible resistance. So here impedance is nothing but resistance. Here this amplifier, buffer amplifier or voltage follower it converts the voltage of high impedance, that means high resistance, to the same voltage of low resistance, that is low impedance. So in this, the output voltage and the inverting end of the voltage is same. So the gain is, what is the V naught by VI? V naught by anybody? Anybody? What is V naught by VI? Is anybody? Here both are same. V naught by VI is equal to same. Anybody? What is the gain in the amplifier, in this voltage amplifier? Anybody? Here both the output voltage is same as that of the input voltage. The gain of the amplifier is one. The unity, it is unity gain amplifier. So reduces here in the clearly, it greatly reduces the loading effects in the measurement. That means that the transformer, if you arrange this voltage amplifier, it reduces the loading effects. Thereby, there is no disturbance in the supply. The transfer, it is used in the transformer. That means high resistance transformers. It is this buffer amplifier or voltage follower is used in high resistance transformers. Here what is happening, this buffer amplifier, it converts high resistance of the voltage to the same voltage of low resistance, and the gain of this amplifier is 1. Here the circuitry is a unity gain amplifier. Unity, let's say this is unity gain amplifier, and then it reduces the loading effects in the transformers, that means in measurement systems, loading effects. For example, if the loading fluctuations takes place, what happens means automatically the power is shut off. So there we can use this buffer amplifier or voltage amplifier. So any questions? Anybody? Any questions? Any questions? Can I answer? Any questions? Any questions? So now I will enable again the same quiz. Those who are not written, they can write this quiz again, right? Now I'm again enable this quiz, right? Same quiz only. Actually, last class we have to discuss it up to this point due to some technical issues. We discussed only the little portion. So same quiz, those who are not attempted, you can attempt that. Here, here you have to come regularly to the online classes. So my advice to all of the students, you have to log in through Digiversity. So remember this point. So now here the total strength today is very less. What is the reason? So maybe if I see it is a 95 above 98, 99. What is the reason behind this attendance lag? 79 members are attended now. So what is the reason? So now respond your attendance one by one. So I will take the attendance, respond one by one, fast. Are you understand today's topic? Are you understand or not? Respond to your attendance one by one. Number one. Number one. Number one. Option right. Number 4, 5, 7, 8. 4 present. Okay. 8, 9, 10, 10. Okay, right. 11 is 13, 14, 15, 16, 17, 17. Okay, 18. Okay, right. 19, 20, 21, 22. All right. 23, 24, 25, 25, 26, 27, 27, 28, 29, 30, 31, 32, 33, 33, 35, 36, 37, 38, 39, 41, 42, 43, 44, 45, 46, 48, 48, 49, right, 45 present, okay, 49, 50, okay, 52, right, okay, 55, 54, okay, 55, 56, okay, 55, okay, 56, 60, 60, right, 61, 61, 61, right, 63, 63, okay, 61 is 63, 64, 63, okay, 64, okay, 65, 66, 67, 66, okay, 65, okay, right, 67, okay, 68, 68 absent, 68 present, okay, right, and 68 up, 69 present, okay, 70, okay, 67 present, 70, 73, 74, 75, 75, 76, 77, 78 present, okay, right, 79, 77, 71 minute, 78, 79 present, right, 76 also present, 80 present, right, 80, 81, 81, 83, 84, 85, 85, 88, right, 89, 90, 91, 92, lateral entry 1, 2, 3, 4, 3, 4 absent, 4 present, right, 3 absent, 4 present, right, 5 present, 6, 7, 8, lateral entry 8, 9, right, present 9, 10, 11, 12, 13, 14, right, 15, right, 16, 16, 17, 17, 18, 19, 17 present, 20, right, 21, 22, 20, 24, 23 present, okay, 24, 25, right, present, 26, 27, 27, 28, 28, 29, 30, 30, 31, 32, 33, 32, 33, 33 present, okay, correct. 34, 35, 36, 36, right, 35 present. 37, 38, right, 39, 40, 41, 41, 43, 43, 41, 43. So now I will read the absent is 41 present. 42 is also present. 42. So now I will read the, see here, all of you listen carefully. The absent is 1, 37, 37 present, lateral 37. 18th batch 41 present, already given. 18th batch 41 present. So just all of you listen the absent is 1, 5, 7, 10, 13, 25, 27, 29, 39, 44, 48, 68, 70, 73, 74, 75, 81, 85. And lateral entry 3, 8, 16, 18, 24, 26, 28, 32, 43. So these are the options. Number lateral entry 18, present. 17th batch 66 are present. So already present, I given present. 335 present. Okay. So anybody else? 17th batch 66 present. 18th batch 318 is also present. 17th batch 329 already present. Okay, right. 17th batch 39 option. 17th batch 39 option. Okay, thank you all of you. So now I will end the meeting. Thank you all of you.